Calibration parameters. There are four main parts of HPLC. First is pump, second is auto sampler, third is column oven, and fourth is detector. Each part of HPLC is calibrated with different parameters. Let us see the first part, that is pump. In this we do two tests. First is flow rate accuracy, second is gradient composition. Second part of HPLC is auto sampler. In this we do three tests, that is injection volume accuracy, injector linearity, and carryover. Third is calibration of column oven. In this we do one test, that is column oven temperature accuracy. And the last is calibration of detector. In this we do two tests, that is detector wavelength accuracy and detector linearity. Let us see the first parameter, flow rate accuracy for pump in details. So first put all the channels, that is A, B, C and D port inlets in reservoirs of HPLC grade water. Set the flow rate at 0.5 ml per minute for port A. Collect the HPLC grade water from column inlet into a dry 10 ml of cylinder and start the stopwatch simultaneously. Stop the stopwatch when the lower meniscus reaches the 10 ml mark on the cylinder. Record the time taken to fill 10 ml cylinder. Similarly, check the flow rate for 1 ml per minute and 2 ml per minute for port A. Similarly, check the test for rest of the ports, that is port B, C and D. Acceptance criteria flow rate. The flow rate should be within plus minus 2.0% of the set value. Let us see the calculation part for flow rate. Here is the formula for flow rate. Flow rate is equal to actual time divided by theoretical time into set flow rate. Here is the table given for your better understanding. For 0.5 ml set flow rate, the time taken to fill 10 ml cylinder will be 10 minutes. So that is equal to 1200 seconds. So theoretical time will be 1200 seconds and actual time we observed it is 1190 seconds. So by calculating flow rate for 0.5 ml, we get value 0.496. You can see in the table, and the limit for set flow rate for 0.5 ml is 0.490 to 0.510. So 0.496 we got the result. So that is in the limit. Similarly, for 1 ml, theoretical time is 600 seconds. Actual time we got is 594. So by calculating by flow rate formula, we got 0.990, which is in the limit, that is 0.980 to 1.020. Similarly, for 2.0 set flow rate, theoretical time is 300 seconds. Actual time we observed, that is 296. Flow rate we calculated, that is 1.973, which is in the limit, that is 1.960 to 2.040. Let us move on to another test, that is injection volume accuracy. First, purge the instrument with HPLC grade water. Fill the HPLC vial with water and close with a cap. Weigh this vial and record weight in grams, that is W1. Program HPLC system with a flow rate of 1.0 ml per minute with water and runtime of 1 minute. Inject 10 microliter from HPLC vial and repeat it for 50 times from the same vial. After completion of 50 injection, remove the vial and weigh again as W2. Calculate the average volume in microliter injected per injection using formula. So formula is injection volume in microliter is equal to W1 minus W2 into 1000 divided by density into number of injection. Here note that density of water at 25 degrees Celsius is 0.0 99707. This you have to use in the calculation. Similarly, repeat the procedure for 20 microliter and 100 microliter by changing the number of injection to 25 times and 5 times respectively. Here is the table for injection volume accuracy, and I will explain calculation for first 10 microliter injection for your better understanding. For 10 microliter injection, we inject 50 injections. So weight of vial plus water before injection W1 gram, suppose it is 4.01000 gram, and weight of vial plus water after 50 injection, that is W2 gram, is equal to 3.51000 gram. So weight of water, that is W1 minus W2 gram, is 0.5000 gram. By using the formula injection volume and calculating, we get 10.03 microliter, and acceptance criteria for 10 microliter is 9.8 microliter to 10.2 microliter. So our injection volume for 10 microliter is in the limit, that is 10.03. Similarly, you can do for 20 and 100 microliter calculations. Now move on to next parameter, that is detector wavelength accuracy. Let us see the chromatographic conditions. Column is C18 150 into 4.6 mm 5 micron or any equivalent. Column temperature is 25 degrees Celsius. Flow rate is 1 ml per minute. Mobile phase is methanol water in the ratio 30-70. Injection volume will be 20 microliter and run time is 10 minutes. So caffeine solution preparation, you have to prepare 25 ppm caffeine solution. For this, you have to weigh 25 mg of caffeine in 100 ml volumetric flask as 60 ml of water. Phonicate for 5 minutes and dilute to volume with water. Further dilute 5 ml of above solution to 50 ml with mobile phase. Next parameter, that is detector wavelength accuracy. First we will see for PDA detector. In this, inject caffeine solution and record chromatogram in the spectral range 190 to 400 nanometer. Note down maxima at about 205 nanometer, 272 nanometer and minima at 245 nanometer wavelength. In this, you have to inject caffeine solution and only once and record the spectral range and find out the maxima and minima. Next is wavelength accuracy for UV detector. In this, you have to inject different solution at each wavelength. So inject caffeine solution at wavelength 200 to 210 nanometer and record wavelength for each nanometer and note down wavelength for maximum area of caffeine peak. Similarly, inject caffeine solution at wavelength 240 to 250 nanometer, record wavelength of each nanometer and note down wavelength for minimum area of caffeine peak. Similarly, inject caffeine solution at wavelength 268 to 278 nanometer, record wavelength of each nanometer and note down wavelength for maximum area of caffeine peak. Here is the table given for detector wavelength accuracy for UV detector for your better understanding. So wavelength is 200 to 210. Here you have to write down the area and here you have to note down the maximum area at wavelength maximum. Acceptance criteria for 200 nanometer to 210 nanometer wavelength, maxima should be at 205 plus minus 2 nanometer. For 240 nanometer to 250 nanometer, minima should be at 245 plus minus 2 nanometer, and for 268 nanometer to 278 nanometer, maxima should be at 272 plus minus 2 nanometer. Let us move to next parameter, that is column oven temperature accuracy. In this, place a calibrated digital thermometer probe inside the column oven, close the column compartment properly Set column compartment temperature at 20 degrees Celsius. Take sufficient time to the oven temperature to reach and stabilize at set temperature. Record the result. Repeat the procedure for 30 degrees Celsius and 60 degrees Celsius and record the results. Here is the table. Set temperature 20 degrees Celsius and limit is plus minus 2 degrees Celsius, that is 18 to 22 degrees Celsius. And for 30 degrees Celsius limit is 28 degree to 32 degrees Celsius, and for 60 degree limit is 58 to 62 degrees Celsius. Now let us see the next parameter, detector linearity. The chromatographic conditions are as follows. Column is C18 150 into 4.6 mm 5 micrometer or any equivalent. Column temperature is 25 degrees Celsius. Flow rate is 1.0 ml per minute. Mobile phase is in the ratio methanol water 30/70. Injection volume is 20 microliter. Runtime will be 10 minutes and wavelength is at 272 nanometer. We will prepare 25 ppm caffeine solution. For this we weigh 25 mg of caffeine in 100 ml volumetric flask, add 60 ml of water and sonicate to dissolve and dilute to volume with water. Further dilute this 5 ml of above solution to 50 ml with mobile phase. Method for linearity of detector response. Inject the triplicates of 5 microliter, 10 microliter, 20 microliter, 50 microliter and 100 microliter of caffeine solution. Calculate the mean area percentage RSD, and percentage RSD should not be more than 1.0 percentage. Plot the graph of injection volume against area for the linearity of detector response. Calculate the correlation coefficient, and correlation coefficient should not be less than 0.999. In this test we cover both injector and detector linearity as we plot the graph of different injection volume and compare it with detector response. Now let us see the carryover test. The chromatographic conditions are as follows. Column is C18 150 into 4.6 mm length and 5 micrometer diameter or any equivalent. Column temperature is 25 degrees Celsius. Flow rate is 1 ml per minute. Mobile phase is prepared in ratio 30/70 methanol water. Injection volume is 20 microliter. Runtime is 10 minutes. Wavelength is 272 nanometer. For carryover test, we prepare caffeine solution of 1000 ppm. We weigh 50 mg of caffeine and transfer in 50 ml volumetric flask. Add 30 ml of water, sonicate to dissolve and make up to volume with water. Method. In this, first we inject blank, then caffeine solution of 1000 ppm, then we again inject blank for carryover. Ideally, there should not be any traces of caffeine. If it is there, then we calculate carryover by the formula. Carryover percentage is equal to carryover area at RT of caffeine in blank divided by test area, that is caffeine area of 1000 ppm into 100. But it should be in the limit, that is acceptance criteria is not more than 0.01 percentage. Thank you.